3 minutes past the top of the hour, and with us right now is Rob Manning. He is the chief engineer for the entire Mars Science Laboratory mission. And everybody is still very conscious of this communications issue, whether or not we will know for sure if Curiosity landed okay, and we'll know it.
Yeah. Yes, well, we do have a fantastic, excuse me, I'm just finishing the peanuts.
He's eating peanuts. Sorry.
We have a fantastic array. We've got three spacecraft, Odyssey spacecrafts flying overhead, Mars Reconnaissance Orbiters flying overhead. We even have Mars Express, European Mars Express overhead, as well as these tones that we're sending back to Earth directly. So I think we have a video.
We have a video, and maybe you can kind of walk people through it
to
understand
let's give it a try.
this. Okay.
Yeah. Okay, so as MSL approaches the atmosphere, we'll first have a straight shot of Earth looking backwards from behind us. Earth is to the left of that view. The great thing is, as it's coming in, we have two orbiters. You'll see them come into view in just a second. First, MRO from the south working their way north, and this is about the time that MRO is recording information that MSL is sending out to the world. At the same time, Odyssey, which is coming in from the top part of the view, is listening to what MSL is doing. And right now, MSL is sending information through Odyssey, and Odyssey is repeating that information straight back to Earth. And that's what we're seeing in this room tonight.
And you see where Odyssey is, where it is on the horizon, and how far it is. And that's one of the reasons why we have a very narrow window when we can...
This is a pretty tricky dance. It's been very well choreographed. People like Brian Schratz have done a fantastic job of making sure that all the coordination is happening. But it's it's easy for this not to work. One of the problems is the antenna is moving around. It gets blocked by equipment as it falls apart. The vehicle comes apart. It is something that you can't rely on in a guaranteed sort of way. So if the signal stops, we stop getting signal, it doesn't necessarily mean that there's anything wrong.
So we will know fairly soon in the next several minutes whether or not Odyssey's move did indeed work, and that it will be in position for us to be able to hear
That's
from.
right. Odyssey had to get into position, it had to stow its antenna, the one that goes back to Earth, turn the vehicle so it's pointing at our vehicle, and then restow the antenna and start transmitting. So what it hears from the rover, it can repeat back to Earth. But that process means that it had to stop talking to the Deep Space Network for a while while it was doing that. And that's happening right about now.
So the point is that people shouldn't get too excited if we don't hear from the rover
That's
landing?
right. We've had problems with communications all along. I mean, in fact, one of the reasons we put so much effort into this is so that if we do have a real problem, we can use this information to deduce what may have gone wrong. And so that's why this information is so essential. But if we don't get it and we land safely, that's still okay too, even though it's just nerve-wracking.
Okay, so Rob, we're going to keep you here while we go through entry, descent, and landing. He'll be there to give us his wise knowledge in all of this. But meantime, let's go back into the MSA and get ready for entry, descent, and landing.
Things are looking pretty good right now. I'm getting a report right now from Odyssey that they're in position. They're going to be there for us for EDL. So they have reacquired to the Earth, and we're good to go. So we will have coverage throughout EDL, through a little bit from about a minute and a half after entry, through touchdown, and then some. So hopefully we'll see all the way to the bottom and see a successful landing. Okay. The EDL activity lead is about to narrate what's going on in the spacecraft. We're entering the EDL prep anchor. That's EDL flight software mode, so let's listen in.
You can see that the nav filter is dropping to the correct state. IVP has stopped, and the EDL prep anchor is complete. Okay, copy that. We're about 3 minutes from the HRS anchor action starting.
The activity lead has told us that we've turned off the attitude control system, the cruise attitude control system. We don't need it anymore. We're standing by for heat rejection system vent. That's the coolant that's been keeping us cool through all of cruise. We'll vent that ahead of cutting the cruise stage. So we're coming up on cruise stage separation.
Go ahead, Phase.
Anytime you guys want to shoot me any results from the sims to me via email, I guess is the way we're going to go now, because the screens are going to transition into having your beautiful faces on it instead of your estimates from the
Flight EDL, the EDL HRS actions have begun. Roger.
Phase, we should have our EDL viz on there when we get UHF data.
Roger. I'm still open for receiving best estimates as they come in on the landing location off of the time point correlation.
Copy, I understand, and we are on it. You will get it in the usual communication window.
Flight EDL, the expected warnings for the Electra hail mode are received. Copy.
The EL team is running some final simulations to show where we think we're going to end up based on the latest navigation data. Things continue to look good. It puts us right in the middle of the ellipse.
Okay, flight, we can confirm the BCB actions have been commanded, and through EHA we can confirm that the discharge beds are now in manual discharge.
The vehicle power changes in preparation for cruise stage separation. It's going to cut loose the cruise stage and all that solar array that's been powering us through all of cruise.
Pyro firing cards are now powered on.
Go ahead, EDL Com.
So we're ready to switch the displays over to the 1010 marker, which will show EDL data manual tones. You ready?
Standby 1. Yes, we are ready.
Copy that. All right.
And we can confirm through EHA now that the BCBs are in manual charge mode.
Copy. BCBs in manual charge.
We've also completed enabling the pyros commands. We are in the process of powering off the cruise stage hardware. And we can verify through telemetry that the cruise stage hardware is powering off.
Yeah, the cruise stage is turned off.
Flight, Pyro bus is armed.
Copy. Thank you, Pyro.
And enabled.
Pyroelectronics that are used to activate many of the devices that are going to be used to cut the cruise stage, and a lot of the separation events during EDL have been armed. Nav is confirming that we are starting venting. HRS vent has started.
And flight EDL, we're firing our first pyros to vent the HRS system. The medley RTDP warnings are expected.
The navigation team can see that the fluid coming out of that heat rejection system is actually pushing the vehicle a little bit, as expected. So we can confirm that the vent is actually happening.
Odyssey Com, Odyssey Mission Manager on EDL Ops.
EDL Com, this is Dynamics on EDL Ops.
Go ahead, Dynamics.
Is our display configured correctly for you in the MSA?
Affirmative. I see it. Waiting for X-band tones. Very nice picture. And we're expecting tone start at 5:13:17 UTC.
Copy.
We're under 2 minutes from cruise stage separation.
Odyssey Com, Odyssey Mission Manager on EDL Ops.
Odyssey Mission Manager, this is EDL Ops on EDL Ops.
Odyssey has completed its salute of the EDLCOM attitude. All systems are nominal. Odyssey is go for EDLCOM support.
Great to hear from you. Thank you very much.
We have a cruise stage step about to happen.
For all of EDL, so we will have their coverage. Things are looking good for them, and they're looking good for us. We're about 1 minute to cruise stage separation.
We're seeing the transition to tones now. The system should be configured shortly. And we're seeing carrier only.
The vehicle's changing to tones at this time. So we're switching from telemetry. We lost telemetry, and we're going to move to just tones.
EDA acquisition. And we're seeing heartbeats.
We are receiving heartbeat tones at this time.
Affirmative, we're seeing the expected 2 seconds of heartbeat, followed by the 10-second carrier pulse.
Nav can see something that could be consistent with cruise stage separation in the Doppler.
And we're showing a good strong signal, higher than expected carrier power, and continuing seeing heartbeats. EDLCOM tones look good.
We are receiving heartbeat tones at this time. Things are looking good. You see that we are priming the entry RCS thrusters. Cruise stage separation. In about 1 minute, Curiosity's EDL software will wake up and begin final preparations for entry. The first action it'll take is to fire some warm-up pulses to get the entry RCS thrusters going. The pulses will ensure the spacecraft will get the thrust that we want when it's counting on it.
We did see the heartbeat signal drop low for a second as the signal passed by the donut of the cruise stage.
We are seeing RCS warm up.
Flight, this is enough.
Yeah, flight, go ahead.
Could you check with DAs whether we should be seeing one-way data from the station?
Base, did you copy?
Curiosity is reporting that it is spinning down and turning to entry.
Flight HS, we've been one way for a while now.
Roger that.
But currently we're just seeing the tones, obviously. Roger.
Vehicle's reporting that it has completed its turn to entry and spin down, and it has separated the cruise balance mass devices. At this time, the vehicle's just sending heartbeat tones, just as we expect. It should be quiet for the next several minutes, hopefully. We are about 7 minutes to entry. At this time, Mars is actually pulling Curiosity in, and we're speeding up. We should be traveling around 5.4 kilometers per second on our way to about 5.9.
So, Rob, what are your thoughts at this point?
Well, I'm very
variation
excited.
in the pattern, antenna pattern is
This is
reflected
the,
in variation.
This is the part that really is entry. This is where we're getting to the top of the atmosphere. The great thing is that the propulsion system's shown to be working. We're turning the vehicle. It looks like the vehicle is going to be doing its entry job very well, and I'm very excited about that. Everything is going very well.
Right.
So make sure everyone keeps their eyes on the television, because we might actually get some pictures, if all goes well, and we might be murky and covered with dust when we first land. But we might get some pictures today.
Wow. At landing.
Just a few minutes after landing.
Excellent. Okay, we're standing by.
Thank you.
We're just under 6 minutes to entry. We're continuing to wait for entry interface. The spacecraft is continuing to send heartbeat tones, telling us that everything is okay and there's nothing significant to report. This is as expected. It should be quiet for a little while, at least. We're now 5 minutes to entry. Continuing to receive heartbeat tones. Everything is good. At this time, Curiosity should be up to about 5.5 kilometers per second.
So what's taking place now?
So right now the vehicle is flying through space. It's actually in deep space still. In fact, not until after we hit the entry point will we actually begin to feel the force of the atmosphere gradually building on that heat shield. So really it's still a spacecraft. It hasn't actually become an aircraft. But we've checked out its rockets. It's actually used to turn the vehicle. It's turned to the right attitude, and that means it's ready to go. And as soon as we start feeling the atmosphere, it'll start doing its role to get to the turn as part of the guidance that it does. It starts off with a right bank, and eventually will make a left bank, and then make another right bank as it makes its way to the landing site.
So it's a capsule right now.
It's a
headed
capsule. It's just a bare capsule, nothing looking out. Just the radios is the only thing that's sticking out, and that's what we're getting. We're getting tones from that vehicle right this second.
Okay.
Now we're not getting Odyssey data yet. That doesn't happen until a little while later.
After parachute.
Actually, just after entry, about the time before parachute, just before parachute opens up.
Okay.
EDL phase dynamics.
Did that work out?
Go ahead, dynamics.
Just FYI, OD227 run out looks like missed distance of 232 meters. Over.
232 meters?
That's correct. Less than the divert.
Roger.
We can expect a brief signal dropout when we switch to the TLGA.
We're at 3 minutes to entry. At this time, MRO should begin picking us up. But remember, we won't get that data for a while. It's got to store it and then send it back down here for us to decode. We're still seeing heartbeat tones. Everything looks good. Spacecraft should be up to 5.6 kilometers per second.
We're on top of 227. See that? No.
2 minutes entry. The EDL team is reporting that the latest runouts, which is using the latest nav, our best guess of where we are, show us that the best guess of our landing target location is about 232 meters from the landing target. So looking good so far. We're continuing to receive heartbeat tones. Everything looks good. We're about 90 seconds from entry.
Flight dynamics, EDL phase.
Go ahead, phase.
That last solution was with 227 or OD228?
That is OD227.
Thank you. You guys have now OD228 in your possession?
There will be no 228 for us, phase.
That's just fine because the difference is
1 minute to entry.
Within spitting distance.
Affirmative.
The vehicle will switch antennas shortly. We'll have a short dropout when that occurs in the tones, switching to a tilted antenna that will be used through entry.
Right,
30 seconds to entry.
As we come up on entry, we'll expect a 2 or 3 second outage in the X-band signal as we switch from the ELGA to the TLGA.
We're switching to the TLGA. Signal's dropped. And it's...
We just saw the signal drop. That indicates we changed antennas.
We're seeing heartbeat tones again after the switch. Things are looking good. We got tones back again. Coming up on entry. Vehicle reports entry interface. At this time, it will begin pressurizing the propulsion system to increase the thrust of the system. It'll use that for all the maneuvering in the atmosphere we're about to do.
Back to heartbeat tones.
We are standing by for guided start and the start of guided entry.
Nav can see the entry in the atmosphere in the Doppler.
We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. It is starting its first bank reversal. First bank reversal complete. We have seen peak deceleration. We've passed through peak heating and peak deceleration. It is reporting that we are seeing Gs on the order of 11 to 12 Earth Gs.
Flight GDSA.
GDSA flight go.
We are processing data from Odyssey.
Bank reversal 2 is starting. We are now getting telemetry from Odyssey.
All right.
Bank reversal 2 complete.
Copy. Bank reversal 2 complete.
Thanks.
Standby flight. We have a connection, but we actually do not have any data yet.
Copy.
We can expect some intermittent contact at this time as the signal increases to respectable levels.
There we go.
We are now seeing
And we have
from
our
Odyssey.
CDPs.
Okay, copy.
And visualization is updated.
We have entered heading alignment.
There it goes.
At this time, Curiosity is no longer trying to control how far it's flying downrange and is just heading directly for the target.
End of range control, air used minus 1.2 kilometers.
Minus 1.2.
1.2.
The EL team is reporting that that things look pretty good at the end of range control. We have converged a lot of the error, and we should be heading toward the target.
Flight EDL, TDS warning is okay.
Copy.
Power on.
We are seeing a tone from
the 1 gigahertz.
indicating that we have seen heating on the heat shield through the Medley instrument. Everything looks fine. This is as expected. During the setting alignment phase, we're flying almost horizontally like a plane. We're going about Mach 2.4 at an altitude of 17 kilometers or so.
Way better.
Vehicle's reporting heartbeat tones again, indicating that everything is fine during heading alignments. We are standing by for straighten up and fly right and parachute deploy. Vehicle's continuing to decelerate. We're down to about Mach 2. As a reminder, we should have parachute deploy around Mach 1.7. We're at 15 kilometers altitude.
We've begun entry balance mass jettison. The predicted mid downrange is 1.597 kilometers.
EDL Ops, Odyssey Systems on EDL Ops.
Parachute deploy. Parachute. Thrusters have been re-enabled. We will control our attitude on chute. We are decelerating.
Wrist mode under
our 10 kilometers decelerating and descending. We are at 150 meters per second.
Dynamics phase. Come back again with wrist mode dynamics.
Wrist mode is nominal.
We are 9 kilometers and descending.
Active. Valid range.
Net filter converge with a velocity correction of 0.7 meters a second.
We've acquired the ground with the radar.
An altitude of 8 kilometers.
Speed chill has separated. We've found the ground.
Expand tones due to earth occultation as expected.
We're standing by to prime the MLE engines in preparation for powered flight. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending.
Flight EDL, we got some tweeter warnings. It is in battle short mode, so it should power through them.
Direct Earth communications at this time. We may have lost it already. We're down to 86 meters per second at an altitude of 4 kilometers and descending. We've lost tones from Earth at this time. This is expected. We're continuing on Odyssey telemetry.
Ground solution equals minus 10.8 meters, vertical velocity of minus 82.8 meters per second.
Start enabled, standing by for backshell separation.
Signal to Odyssey is still strong.
We are in powered flight. We're at altitude of 1 kilometer descending, about 70 meters per second.
Signal to Odyssey remains
down to 50 meters per second, 500 meters in altitude. Standing by for sky crane.
Constant velocity accordion nominal. Altitude error 5.9 meters.
We found a nice flat place. We're coming in ready for sky crane. Down to 10 meters per second, 40 meters altitude. Sky crane has started. Descending at about 0.75 meters per second as expected. Expecting bridle cut shortly.
Signal to Odyssey remains strong.
Tango Delta nominal.
Yeah. EDLCOM configured.
Rim stable.
UHF telemetry.
Rim stable.
UHF is good.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us. At this time, flyaway should be complete. The set stages at a safe distance. We are continuing to receive telemetry from Curiosity. We're safe.
Getting data from the surface of Mars.
ASCAM sequence is kicked off, waiting for images. Heads up, folks!
EDL ops, the signal to Odyssey remains strong.
Flight EDL images are starting to come down.
We're beginning to get images,
we got
from
images
Odyssey.
coming down, folks. Video comm configure
Stand by for images.
Reader has
Seeing
cam
thumbnails coming down.
Odyssey data is still strong.
Odyssey data is very strong.
Odyssey is nice and high in the sky. At this time, we're standing by for images.
Thumbnails are complete.
We got thumbnails.
Whole image complete.